Okay, good morning everyone. Welcome to Monday. It's almost Friday. So we're going to be discussing finally this if-then-else statement today. We're going to go very slowly because though it seems simple, it can actually get a little bit complicated. But before I do that, there's just one thing I want to show you with regards to assignment 1, which I hope you guys have seen that it's posted. So I at least recommend that you go read the assignment, right? Just read the questions so you can start thinking about it. You don't have to start doing it, but generally I find it a good strategy that when given an assignment or any work to do in university, to read it immediately, right? So you can think about it in the shower and on the bus, and plus subconsciously your brain actually works on these problems. So the same is true of taking a test. When we guys give you your midterm, I'm going to give you a little bit of more testing strategy. But one thing you should definitely do when given a test is to read it, the whole thing, before starting. In fact, in Australia, we have something called, I forget what it's called. It probably had some crazy Australian name. But the point is, for the first 10 minutes of the exam, no one was permitted to write. You were only permitted to read. And that was actually a fairly good idea. So the thing that I want to show you, which will be useful for your assignment, is the math library. So I didn't show it to you because I didn't want to explain to you what this import does. So let's ignore most of the meat there, but suffice it to say you can import a library called math, like this, and then you can use things from math, like math.py, math.sine of math.py, math.cos of math.py. Why is math sine of pi 1.2? So I guess this is in, oh, it's 1.2 to the e to the minus 16. Okay. So remember how I was talking to you about reals or floats and how sometimes they like screw things up in the system? So I was expecting math of sine to be, I was expecting sine of pi to be 0. So what is this here? I don't know if we've ever discussed this, but this is scientific notation, right? This means 1.2 times 10 to the power of negative 16, right? So this is a number with 0 decimal, 15 zeros, 1, 2, right? So it's effectively 0, but not exactly 0, right? So this is a good illustration of the trouble that you encounter when trying to do numerical computation, right? Things that are supposed to be 0 just sometimes aren't 0. So before I begin today's lecture, let me mention that we've already seen a simple if statement. We've seen the inline if statement. So I can say something like x is 7 if true, else 6. And what do you expect the value of 7 to be here?
You mean the value of x?
The value of x. The value of 7 would be 7.
The value of 7 would be x.
And the value of 7 would be x, yeah. If I try to print out, so if I say x is equal to 7 if true, else it's 6, right? So what would you expect 7 to be in here if I read that sentence like that? X is 7, right? Maybe you need some more warm-ups. So I'm going to say y is equal to 0 if x is less than 7, else it's x. So what should the value of y be?
7.
Okay, so let's walk through this, right? So y equals 0 if x is less than 7. So what's the value of x? 7. Is 7 strictly less than 7? No. So this is false. So it goes to the else. And it says else 7. So y gets 7. Oh, I forgot to list a y there. We can also use these inline if statements in returns, which are kind of handy. So I can have a function here, call it f. I can return hello if x is greater than 0 and else world. So if I call this function f of 1, it should return hello. Okay, so that's the inline one. That's the simple one, right? This is simple because it only gives you an opportunity to do a single branch, right? If something's true, set it to this. Else, if it's not true, set it to false. Right? So we can have, I don't know why, this should be if. I don't know why that's inline. This is how a if statement looks as if I were to draw it as a flowchart. So I don't know if you've seen these before, but diamonds usually indicate decisions, And these blue blocks just indicate sort of code statements, right? So in that last inline statement, this if x is greater than 0, I can sort of draw it like this. I can say I have a condition that I'm testing, and in this case the condition is x greater than 0, and if this condition is true, then I'm going to return hello, and if this condition is false, I'm going to return world. Right? So we can draw pictures like this to describe these if statements. More generally, an if statement is given some condition, which is a predicate. Right? That is, give me some statement that evaluates to true or false. Let's call that a condition. An if statement is a control structure that executes a block of code when C is true. Right? So that's the formal definition, or formal-ish definition. I think this is more easy to understand through a diagram. So we'll do a diagram after this. First, let me give you the general form in Python. Right? So if you want to write an if-then condition in Python, it looks something like this. You say if condition colon, and then everything has to be indented. Right? And then everything that's indented here is considered part of the if code block. Right? So remember, in Python, spaces matter. And in this case, only code indented within the if statement gets executed. So if this code block was unindented, it's no longer considered part of the if statement, which is much different than programming languages like C or Pascal or Java, where code blocks are indicated by braces. Right? So you really have to be careful with your spacing here because Python uses it. Here's the picture of that if-then statement. So that if-then statement looks something like this. You give me some condition C. So if the condition C is true, then some code gets run, and then we continue with the program. If I get to this decision and the condition is false, then we just continue with the program. This code block is skipped. Geez, what is going on today? Oh! So generally, we don't write this, then run this code. It's sort of implicit of rectangles that they contain code, right? So I can simplify this diagram to look more like this, right? If this condition is true, then run the if code. If the condition is false, then just continue with the program. So that's what I mean by continue, right? There's the rest of the program that you just go and execute. So here's some examples. Here's a simple one. I'm going to set x to 1, and I'm going to say if true, then set x is equal to x plus 1. So what should x be here? So do we execute this code block? Yes, right? Because maybe I should have put an actual condition there, but I'm trying to keep it very clear. Right? So if true, right? So this is going to execute. So if true, execute this code block. So we're going to execute the code block. X is going to get 1 plus 1. So x should be not 0. That should be 2. I don't know why that's 0. So that's my first mistake of the day on page 8. Okay, here's the next one. I'm going to say x is equal to 1 over 1. And this is a twofer. I can say if the type of x is an integer, that's how you do a type check, then x gets x plus 1. So what does x get here? So let's walk through this. So x is 1 divided by 1, which is what? Which is what specifically? 1.0, right? Because this is not an integer division. So what's the type of x? What's the type of 1.0? It's a float, right? Is a float an integer? No. So this condition fails. So this code is skipped. So the value of x is 1.0. Oh boy. It's going to be a rough one today, guys. Buckle up. Okay, here's another one. All right, I'm going to start trying to combine all the stuff that we learned so we can reinforce other weeks, right? So I'm going to give you a string. Okay, so there's mumbling, which usually indicates that there's confusion, right? So can someone ask a question so I can help unpack any confusion? Does anyone have a question? Because this stuff is a little bit hard. Yes?
For that condition, is a comparative integer, or would we have to basically put a double equal sign to 1.0?
Where are you getting the 1.0?
Well, because of the integer division converts to a float.
Okay.
So when I'm asking if just the condition, right? You're saying type X does that automatically check if it's an integer or
It's going to check what the type of x is, right? So you can have multiple types, right? So x gets cast to a float as soon as you do that division. So it says type of x, float, and it says that's not an integer, right? So that's just a simple type check. Okay, here's another example. So I'm going to say we have x's, a bunch of characters tied together in a string, and that string is our favorite example, hello world. I'm going to say if h is in the string, then x's is equal to goodbye plus x's on that slice. Right? The minus fifth character to the end. So let's walk through this. X's is this string. Is h in x's? Yes. So this condition is true. So this code block gets executed. And it says x's now gets goodbye plus the fifth last character to the end. So it's 1, 2, 3, 4, 5. So this should be the word world. Or sorry, 1, 2, 3, 4, 5. I should have gone to 6. This should be 6. And then I can say x's is goodbye world, which ends up being a little bit more dark than I anticipated it would be. But so be it, right? If someone can find me what the negation of world is, I'm all for it.
Hell?
Yeah, fair enough. I think that would be the negation of heaven. Okay, so here's another example. X's is hello world. If the character A is in X's, I want you to set X's to the empty string. So let's walk through this. Here's the string. Is A in this string? No. So this condition is false. So this code gets skipped, which means X's is hello world. Okay. Another example to really hammer home the difference between print statements and returns, right? Because it seems that no matter how many times I mention it, there's still confusion. So here's a function called foo. And foo takes a value x, and if x is greater than 0, it prints positive. And if x is greater than 10 to the power of 5, it prints a large positive. So if I set the result of foo to answer, and I give foo 10 to the power of 6, what happens? Let's walk through the code, okay? So this code gets 10 to the power of 6. It goes into this if statement. Is 10 to the power of 6 greater than 0? Yes, so it prints positives. It goes to this condition now. It says, is 10 to the power of 6 greater than 10 to the power of 5? Yes, so it prints a large positive. Then, because we didn't write a return in here, it's going to return none. So my prediction is that this is going to print positive and large positive, and then assign none to answer. Right? So it prints positive, then large positive, and then the type of answer is none. Right? So just because one if statement executes doesn't mean the next one gets skipped. Right? These are multiple if statements that are sort of in sequence. Alternatively, what happens if I define a function called bar? It's defined in the exact same way, except I've swapped the prints for returns. And now I say answer is equal to the function evaluated at 10 to the power of 6. Now what happens? Huh? The string positive is returned, right? So nothing gets printed, right? And the type of answer is string, and answer is in fact set to positive, right? So in foo, the if statement was printing something. In bar, a string is being returned to the user, right? That's much different. Also notice that as soon as we hit this return, the whole thing we left the function, right? This never got an opportunity to execute. Because remember, as soon as a return executes, we leave the function entirely. If false, answer is equal to 0. What's the value of answer? So what would you expect if you typed this? So let's think this through, right? Whenever I ask for a variable in Python, it has to exist. Otherwise, it's going to say, this variable doesn't exist. In order to make a variable exist, you have to assign a value to it. So let's walk through this. So if the first thing I type is if false, is this code block going to get executed or not? No, well, it's very clearly no, right? That's just why I'm writing these. I'm writing if false and if true, right? So this definitely doesn't get executed. So does answer have a value? So what should Python throw? Error, right? So this is literally skipped, right? Python doesn't even like reserve space for the value answer. It says, oh, this is false, so I don't care. I'm just going to jump over that, right? So do you have to keep that in yes? Or is that a stretch? That was a stretch. Looks exactly like raising a hand, right? Just stretching, professor. Okay, so here's a way that we could use an if statement in a real program, right? Suppose you wanted to know if someone was, if you should be printing people's records in the black or in the red. I don't know if this is sort of a universal thing, but to be in the black in your bank account means you have a positive balance. And to be in the red means you have a negative balance. Right? So I can have some type of code statement in my program that says, if the balance is greater than or equal to 0, then set in the black to true and in the red to false. If the balance is less than 0, then set in the black to false and in the red to true. Okay? So this is kind of ugly for two reasons. One, it makes our code longer, because I have to write 2 if statements. Second, it has to check the condition twice, right? So it has to be the case that either this is true or this is true, right? These are in fact the converse conditions. So suppose this, like when you check a condition, that could be expensive depending on the sort of the content of the condition. So the fact that I have to check the condition twice could be a source of slowdown. So in order to avoid this, we're going to add a little bit of decoration to our if statement. And the decoration we're going to add is this else. Right? So we had if then something. Now we have if condition, then run this code, else run this code. And the else sort of captures everything that the condition doesn't capture. Right? So this is a branch that will definitely execute new code. Right? So in an if then else statement, if the condition is true, then it runs some if code. If the condition is false, then it will run some else code. And then in either case, we continue running with the program. So here is the other piece of code that I said looked kind of ugly, rewritten. Right? So I can say if the balance is greater than or equal to 0, then execute this code block, else, which means if this fails to run, if this code doesn't run, then this code for sure will run, right? So if in an if-else statement, extra code is for sure getting ran, right? You can't skip these both. The else statement will always run something if the first condition fails. Okay, so now we have an if statement. So now I can actually write a function that does this. So we did this last week with the inline if. This week, let's just do it with the full if statement, just for practice. So I'm going to boot up my terminal here. I'm going to go to my desktop, if it will let me. I'm going to touch monday.py and just open that. Okay, so there's my IDE. I'm just going to check that this is all working, right, as I usually recommend. So Python 3, Monday. Great, we're at the races. So I want to define a function called, write a function that returns the longest of two strings. Okay, so I'm going to call this longer string. It's going to take string 1, a string. I'm going to do it the old way. String 1, string 2. I'm going to write my doc string. 1, 2, 3. 1, 2, 3. By the way, your doc string also has to be indented, right? Because it is included in the definition of longer string, right? So that seemed to be a common mistake. So the signature here is it takes two strings and it returns a what? A string, right? It's going to return the longer of two strings, returning string 1 when there is a tie, right? So maybe longer string of fancy and pants is what? Fancy. Maybe longer string of amazing and empty will be amazing. And these actually should be in quotes as well. Great. Okay, so let's use our if statement. Right, so what was the thing that we learned last week? We can take the length of a string using the length option, right? So if the length of string 1 is greater than the length of string 2, then what do I do? Perfect. Return string 1, else, return string 2. Okay. So let's see if this works. I'm just going to call in my function into the interactive mode. I'm going to check that it's there. It's there. And now I can say longer string. Let's try our examples here. Fancy pants. Oh, what did we do wrong? Yeah. Yes. This should be like this, right? So that's why it's good to write these doc strings, right? You can catch yourself making these tiny mistakes. That's an edge condition, by the way. I always have trouble trying to figure them out. So let's try this again. So we have longer string, we have fancy, we have pants, fancy. Okay, fancy and Paul, fancy. Great. Let's just make sure that we're not always returning the first thing. Perfect. Okay, what would be the consequence of doing this? So you're saying this will no longer work?
It will work for that condition, but first the condition which is written, whereas it's like the other way around, if length of string 2 is greater than length 1, string 1, then it won't work.
So you're saying this won't work? Okay, let's look. Okay, so that seems fine. That seems fine. It all seems to be working okay. Is anyone surprised by the fact that it's working okay? No. Right? Because what happens, so if this passes, then this return is correct. What happens if we skip this code block? In order to be at this line, in order to get to line 13, it must be the case that this is false, right? And if it's false, then the string, we should be returning string 2, right? So those are equivalent, in fact it still works. You don't need the else, right? So it's a little nuance in the function, but let's just keep that in mind. Okay, and of course, what would be the best way of doing this, quote unquote? I think probably we'd want to do something like this. Return string 1 if the length of string 1 is greater than or equal to the length of string 2, else string 2. I don't know if necessarily that's better, but it's shorter, right? Let's continue. How much time do I got? Ooh, geez. So there you go. I wrote the answer into the slide, so you don't have to worry about copying it down. Here's another example. Suppose we wanted to check someone's credit score and throw an exception, right, if we can't find it. So with our current if statements, this would get kind of messy, right? So I can say if the credit is poor, print no credit for you. If credit is good, then print maybe credit for you. If credit is equal to excellent, print let me give you credit. So that's fine. Those three consecutive if statements, okay, sure. But what happens then if I wanted to say, well, suppose none of these if statements executed, then throw something like, you need to obtain a credit score. Look how messy this is, right? What I really want is some structure to say, check this, then check this, then check this, then check this, and if all of these fail, then here is the accepting case. Or here's what to do in all other cases. I'm going to add more stuff to our if statement now. So we had if, then I added if, then else, right, to give us a branching condition. Now we're going to add a elif, which is just a short form of else if, right? So we're going to have if condition 0 is true, then run some code. Else if condition 1 is true, then run some code. Blah, 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 blah. Else if condition n is true, run some code. So you can just put in sequence a bunch of conditions. So the new updated structure looks something like this, right? So we enter in our if statement. It checks condition 0. If condition 0 is true, then it executes block 0 and continues. If condition 0 is false, then it goes to condition 1, runs a block 1, and then continues. If this also fails, if this fails and then this fails, then we check condition 2. If it's true, we run block 2 and continue. And if this is false, then we just continue, right? So I only did 3, even though this diagram should work up to n, right? So I put that, if everything false is false, the whole thing is just going to get skipped. And we're going to escape this as soon as one of these things are true, right? So a big mistake that people make is following this path to the continue and then executing the rest of the if statements, right? As if they were consecutive if statements. There's a difference. Maybe I should do an example after this. Okay, so I can now change the messy code from the couple slides back to look like this, right? If credit is poor, then print this. Else if credit is good, then print this. Else if credit is excellent, give this. Else, right? Capture all of those cases. Print obtain credit score, right? So that's a lot more clean. Okay, so here is, let's test. Let me set x equals to true, y is equal to false. And we have to practice now our logical arithmetic, right? So if not x, let's set answer to panda. Else if x and y, let's set answer to snake. Else if not x or y, set answer to badger. So let's walk through this. What's x? So what's not x? So this is skipped. Okay. What? You be good, okay? Otherwise, I'll just hold my laptop above my head like this. Maybe I have some loose connections. All right. Okay, so we determined that the answer isn't panda, which is sad because panda is my favorite animal. So let's go to this one. X is what? True? Okay, true and y is false. So this is false. So this code gets skipped. So we go to this condition. Not x is false or false. So this gets skipped. So the value of answer is error. Nothing gets set in this, right? Which is why we're going to want to add an else, right? Especially if we set a variable in an if statement. We definitely want to say, if it doesn't get set to any of these values, we better set it to a default value of some sort, right? Because when we use answer, I don't want Python to throw a name error. As soon as Python throws an error, that's it. The operation of your code is terminated, right? Even if it's not finished, so. And these are hard errors to find, right? You got to imagine you have thousands of lines of code that you've written, and all you're seeing is, oh, there's a name error among your 1,000 lines of code. Okay, so to correct that slide, right, I want to then take everything that we've learned and make a super if statement, right? An if statement that can have an if, that can have as many else ifs as you'd like, and then finally an else condition which definitely runs. This is basically equivalent to saying elif true as the last one. So this is the full structure of the if statement for two else conditions, even though you can expand this graph to n if you'd like. So it's the same as the other one, with one exception. There is now an else block which executes for sure if all the other conditions fail. Right? So something is going to get set. So let's redo the example. Exactly the same example, except I put else. Right? I have an else statement, and the answer gets set to man, bear, pig. Right? So if I run this, and I ask for the value of answer, this time it's going to be man, bear, pig. Right? Perfect. We can nest if statements. Right? So you can say, if x is greater than 0, then print x is positive. Furthermore, if x is greater than 1, then print x is not small. And furthermore, if x is greater than 10 to the power of 10, print x is pretty big. Right? So, I want to sort of investigate this example more, just so we can see how this is different than the else ifs. So just, let's go into here. I'm just going to get rid of, well, I'm going to make some default function like this. Okay, so foo, what was I doing? We have an x, okay, so I'm going to take x. So if x is greater than 0, I want to print positive. If x is greater than 10, I want to print kind of big. And if x is greater than 10 to the power of 10, I want to print huge number, right? Okay, so let me call that into my Python interpreter here. Is it happening again? I forgot a, thank you. Thank you. So that's not going to work. Okay. So let me call that in. Let's see that we got it. We got it. Okay, so what should happen if I type foo float infinity? It's going to print all three, right? Because it was bigger than 0, and then it was bigger than 10, and then it was bigger than 10 to the 10. Okay, let's change this now. What happens if I do this? I'm going to recall this into the thing, and now I'm going to call foo float inf, right? Now what happens? Is anyone surprised by that? Right? Because this is different than the thing I just wrote, right? If x is greater than 0, then this prints, and we're done. It exits the if statement. It doesn't bother checking any of the else ifs, right? Because this condition was satisfied, so it doesn't need to check any subsequent conditions. I'm going to change this again. What about now? What is this going to print? All three again, right? Because now this condition is satisfied, this condition is satisfied, and this condition is satisfied, right? Consecutively. This was kind of maybe a bad example. I needed to demonstrate some of the nesting branches, but what I'm trying to emphasize here is that there's a big difference between putting if statements, separate if statements consecutively, versus making one if statement. So there are 3 if statements here, right? This is one if statement. If block. This is one block of ifs, right? Rather than 3 blocks of if, right? So please go to the labs and practice, right? Because what happens is it's bad. Well, okay, you can't understand 60% of week 1 and then 60% of week 2 because that will start accumulating, right? You're going to understand 60% of 60% of 60% of 60%, and then you're going to end up understanding nothing. Right? So try and keep up. Right? It's traditionally, you're going to lose all of your time come Thanksgiving. You're going to go to Thanksgiving, you're going to come back, you're going to have 0 time to yourself. So please try to keep ahead of this stuff. And the TAs are actually quite good. So I really recommend that you guys do go into the lab. Finally, next time we're going to talk about code refactoring, which is looking at a piece of code and simplifying it. Because often you guys are going to write really crazy if statements that are a lot more simple than you expect. So see you next time.